Our next speaker is Dr. Tim Hovanec, who is the founder and CEO of Dr. Tim's Aquatics. Previously, Dr. Hovanec was the Chief Science Officer for Marine Land Aquarium Products and Instant Ocean, where he was instrumental in the inception and development of several major commercial products. Dr. Hovanec also holds 13 U.S. and foreign patents, and he's authored numerous papers on aquatic microbiology, water quality, and filtration techniques. Today we're going to hear from Dr. Tim, and he'll be sharing some of his insights into the microbial communities of our reefs as he presents secrets to quickly cycling your reef tank, understanding the science of nitrifying bacteria. Please welcome Dr. Hovanec to the stage.
Thank you. Hi. Thank you very much. My pleasure to be here today. And what we're going to talk about is how to cycle your tank. But we're going to talk about it from the view of how to maximize the nitrifying bacteria. So a little bit about me. I've basically been a fish geek since I was 6 and just turned that into a passion, into a company, into what I've studied. Did my master's in ammonia excretion and ammonia toxicity in fish. Did my PhD on phylogenetics, which is how to classify nitrifying bacteria in aquaria and in Mono Lake, California, using phylogenetic or molecular probes. Only had a few jobs in my life. Hatchery manager, Marine Land Aquarium Products, Dr. Tim's. Peace Corps wasn't a job, it was a challenge, and you didn't get paid. It was fun out in the Philippines. So let's start with the bacteria. The traditional view of nitrification is you have ammonia converted to nitrite, and that's done by Nitrosomonas europaea, and nitrite is converted to nitrate, and that's done by Nitrobacter winogradsky. If you could pronounce the names, you were advanced from novice to an intermediate aquarist, and you were on your way. Short story, that's wrong. These are not the bacteria that do this in aquariums. They are the bacteria that do it in high ammonia systems. They are the bacteria that do it in soils. But in your home aquarium, this is not the bacteria. But that's a whole nother story, which we're not going to talk about because you're not phylogenetic microbiologist. But if you're interested, you can email me or leave me a card, or I can send you that, or you can just go online and Google my papers and read all about it. And if you're an insomniac, that has been cured. So the main thing, though, is nitrifying bacteria are a living part of your aquarium. I used to be a fish guy, and then I was a zooplankton guy, and now I'm a bacteria guy, because they rule the world. So what do I mean by that? Well, you've got fish. You've got to set up your aquarium for your fish, saltwater fish, freshwater fish, brackish fish, maybe Red Sea fish. You have clams, maybe. Well, what do they need? You also have corals, and you talk about how I want to set up my tank for that, how I want lighting, what equipment do I have. But nobody really talks about how am I going to set my tank up for nitrifying bacteria. They add substrate, they add rocks, they add water, and maybe they hope the bacteria come, set it up and they will show up, or maybe they add a bacterial mixture. And full disclosure, I have made, the author or the inventor of 2 types of bacterial mixtures. I'm not talking about those products today. I'm not selling anything, except I'm giving you information from literally 25 years of experience of growing nitrifying bacteria. So, nitrifying bacteria, they vary. The species that will show up in a system vary depending upon temperature. They vary upon the salinity of the water, the pH of the water, the ammonia concentration in the water. A lot of the previous research and the stuff that's still published in books, why do they say Nitrosomonas europaea? Well, that's based on what happens in a wastewater treatment or a sewage treatment plant. The ammonia concentrations are 40, 50 ppm. No fish is living there. And you can't have fish in your aquarium at those concentrations. Why would we expect that the same bacteria would be in that environment in our aquarium environment? They can't. Same with nitrite. That's a big determinant of what's going to appear, what type of bacteria you have in the system. Now, nitrification at its basic This is the only chemistry program equation in the whole talk, but it's important. Okay. Well, maybe this, oh, there we go. The main thing is the bacteria use ammonia. They do not use ammonium. Ammonium predominates at the lower pH, but the bacteria use the unionized form, the ammonia. They need oxygen to perform this biochemical reaction. But, and I'm told, not asked, I am told this on a weekly basis. No way can a bacteria live in a bottle because they can't breathe and there's no oxygen in the water after a period of time. Okay, newsflash, bacteria don't have lungs. They do not need to breathe. They only need oxygen to do this reaction when there is ammonia or nitrite in the water. They do fine in a bottle. And what happens in this reaction, though, the main thing is they're producing hydrogen ions at both sides. When they convert ammonia to nitrite to nitrate, it produces hydrogen ions. And why am I talking about this? Because this will consume your alkalinity and lower your pH. And that's what happens when you start cycling a tank with ammonium chloride or as your tank ages. Why is my pH dropping? Because the conversion of ammonia and nitrite to nitrate produces acid, and your alkalinity is like Tums. It's an antacid. It consumes it, and when your antacid runs out, now your pH is going to drop. It's part of this natural system in the aquarium. And this is the only phylogenetic equation you're going to see, but there's incredible amounts of diversity in the microbial world. When I was an undergraduate, and we're not going to talk about how many decades ago that was, microbiology was about the most boring thing. It was what you could grow over a semester or a quarter on an agar plate. It turns out we can only grow 1 or 4% of the bacteria in any water sample because what we provide them is not really what they need. So flash forward, modern molecular methods using DNA probes and sequencing and clone libraries and all this stuff you see on CSI whatever that take them about 4 hours, but in reality take 4 days or more. You can look at these organisms and you can do things in real time and you can look at the differences. That's how I can tell you what species grow in what environment and how that's impacted, because in real time I can take samples and we can tell if that bacterium is still there or not. I'll cut to the end and then we'll get to the practical matters. Oops. In saltwater aquaria, the ammonia oxidizing species are Nitrosomonas asteri-like and Halophilia-like, and the nitrite oxidizing species is Nitrospira marina-like. It has the like on it because no one has officially done all the work to get it to be an official species. But these are the organisms that are actually doing nitrification in your saltwater aquariums. This is where we grow. This is one of the places we used to grow. There's a tank farm. Many people up here might be talking about how they grow fish. I grow bacteria. Much nicer. Electricity goes out, we're good. You know, hurricane comes, we're good for a few days before we have to worry about what's going to happen to the bacteria. A lot less stress than when I was a fish farmer. Pictures, here they are, right here. We can use what are called molecular probes, some little bit of cookbook, expensive microscope, and the green here, it's not very clear in this picture, but that is the ammonia oxidizing bacteria, and the red is the nitrite oxidizing bacteria. With these tools, we can ask questions. What do they like to grow? What in the substrate, what part of a filter, what type of plastic, those types of things, and what affects them. So a little bit of background. You're going to have fish, you want to understand a little bit about the fish. You're going to have bacteria, understand the big differences, and we're dealing at treetop level here. I'm not going to teach you microbiology in 20 minutes, but there's a lot of stuff out there that you read that's just wrong, and I'm trying to clear some of that up. So nitrifiers are what are called chemolithoautotrophs. And all this microbiology comes from long ago, the German. And in the German language, if you have 3 words, they're going to put it together and make one long word out of it. And so chemo means they attain their energy from a chemical reaction. Litho means they're getting something inorganic. What's the inorganic? Ammonia. There's no carbon in ammonia, it's NH3. Or nitrite, NH2, again, no carbon. And autotrophic means their carbon comes from carbon dioxide. So feeding them like Nopox or carbon sugar isn't going to do anything to increase the number of nitrifying bacteria because they cannot use organic sources. They have to get their carbon from an inorganic source. This will become important in a few more slides. Because of this, they grow really slow compared to their arch enemy, the heterotrophs. There's 2 types of bacteria then, the chemolithoautotrophs and everybody else, which are the heterotrophs. And the heterotrophs, we're going to deal with them in a second, but with the ammonia AOB, ammonia oxidizing bacteria, they can double in every 30 hours. They're very slow growing because converting ammonia to nitrite doesn't release much energy. Converting nitrite to nitrate releases even less energy to the cell, so the nitrite oxidizers take 40 hours. Well, why are you dealing with all this? I just want to know how to cycle my tank. We're going to get there, okay? But it means they're very slow growing, and that's important. Okay? They also, as you're going to see, when you start putting them in salt water, that slows the whole process down. Why? Because the cell has to spend energy just maintaining its shape. The cell has one type of salinity, and then it's surrounded by this very salty water that basically wants the cell to shrink up. And they have to spend energy to make sure the cell doesn't shrivel. So let's deal with this first thing on cycling bacteria. Okay, let's deal with salinity. We're all going to set up a saltwater tank, and you're going to make that up to 34 parts per thousand. Maybe it's a Red Sea tank. You're going to bring the salinity up, and you're ready to cycle, and you want to get that tank going. And I don't care if you're going to cycle with fish, cycle with bacteria. This doesn't matter. Bacteria are bacteria. Well, the problem is, what this chart shows is the fancy title, bioenergetics aspects of halophiliasm, which means how much energy do you get from living in salt? And these are all different types of bacteria. Sorry, this pointer doesn't seem to work right in here. These are different types of bacterial processes. And what you see is many types of bacteria can live from 0 salinity up to 300 grams per liter. This is grams per liter. So this is 10 times. The ocean is 30, 34, 38 grams per liter. Except there's a few that don't make it, that are less tolerant of salt, right in here. Well, that's not good news for us aquarists, because these 2 right here, the autotrophic ammonia oxidation, that's ammonia to nitrite, and even less tolerant of salt is this group, which is the autotrophic nitrite oxidation, fancy word for the autotrophs converting nitrite to nitrate. They can only tolerate salt up to about 40 grams per liter, not that salty. And then the cell basically doesn't divide, maybe even doesn't survive. So what can we do? How can we use this information? Cycling secret number 1. Now we're getting to the meats and potatoes. Lower your salinity. When you cycle the tank, when you first set up that tank, if you're not cycling with fish, you can save some money. Lower the salinity. Go around 18 to 20 parts per thousand. You've lowered the salinity. the cell doesn't have to spend so much time, so much energy maintaining its cell shape, so it can put more energy into dividing, so it can divide faster, and you didn't have to spend as much money on salt right now. Okay? Then, what you can do after the tank is cycled is increase the salinity over 2 or 3 days, 2 or 4 days, to the salinity that you want for your aquarium. The ammonia or the marine bacteria actually can survive and do quite well down to about 8 to 10 parts per thousand. So if you're setting up a brackish water tank and you want to know which bacteria to use the marine. And there are differences. And everything I'm talking about, you can talk to me later. I can show you the published data. All my work is published in peer-reviewed journals. Freshwater bacteria, at about 8 to 10, they're toast. The marine bacteria can actually go down 5, 8. So the marine nitrifiers are much more tolerant of a wider range of salinity. So they do fine in this low salinity water. I was talking about, the nitrous ammonius, the nitrobacter, what we all learned when with spotty and things like that. What's the differences? Well, there's big differences, and it's important about how you cycle. So the main one is that nitrous ammonius europaea grows at high ammonia concentrations. And this is what fooled researchers, because when they would grow nitrifying bacteria, all the manuals said grow it at these high concentrations. Well, we were selecting for these species by having a culture system that only would produce that bacteria. If you have a system like your aquarium that has lower ammonia, nitrous ammonius europaea doesn't grow, this nitrous ammonius marina does. It grows at low salinities, it's slower growing, and most important is it's not tolerant of nitrite. And I'm faster than my fingers here on the slides. But those are important because think about how you're going to cycle. A lot of people, how do they cycle? Well, I just go get some shrimp from the store and I chop it up and I throw it in the tank and I hope for the best and I don't care that it's cloudy or it stinks. Or I'm going to get ammonia and I'm going to go down to Tractor Supply and I'm going to pour some in. And I don't care about the concentration. Now what's going to happen? The ammonia guys grow faster, so they're going to take care of that ammonia faster, producing lots of nitrite. As the nitrite amount grows, the nitrite bacteria don't grow as fast, so that nitrite gets high. It has a negative feedback to the ammonia guys, and it starts inhibiting their growth and stalls the process. So what does that mean? Well, we're going to talk about the nitrite bacteria, is once again, even the nitrite oxidizing bacteria, the group that we want is inhibited, means it slows down when your nitrite concentration is above 5. And they're very slow growing. So cycling secret number 2 is keep both your ammonia and your nitrite below 5 milligrams per liter nitrogen. If you just willy-nilly dump ammonia in there, within a few days, in what happens, even if you don't add a bacterial mix, generally within 8 to 10 days, there's no ammonia, but the nitrite is just off the scale. Every one of those tests is deep purple. The whole thing is not working, and then suddenly your ammonia starts to appear. Why? Because your nitrite is too high. And the best thing to do then is a big water change. And when you change water during cycling, do not disturb your substrate. Don't change your filter pad because these bacteria live on surfaces. They don't live on water. So your friend says, oh, you want to cycle the tank? Here, take some of my water. All you did was get dirty water to your clean tank. The bacteria aren't there. I have filtered and examined thousands of gallons of aquarium water. There are very few nitrifiers in the water. They're on surfaces. So have them give you maybe some live rock or something like that. But using water from an old tank, you're getting almost no nitrifiers into your system. Okay. The other thing then now is talk about where they live. I talked about surfaces. Well, what's important to realize is they live in 100 micron. This is using small probes. You can look at the track here. So this is ammonia in the bulk water above, right in here. That's the bulk water. This is the biofilm. And with this equipment, you can measure ammonia, nitrite, oxygen at 20 micron intervals in very thin films. And what the importance of this graph is that nitrification takes place in the upper 100 microns of a biofilm. Very thin surfaces that you want in contact with your water. So what does that mean? And this is not a knock against these type of highly engineered media, but this type of media with lots of pores, the water has to be able to flow through it. And so if you have an open ceramic or concrete, whatever it is, and the water can flow through it, that's fine. But if it's one of these that's very tight and the water just hits it and flows off and doesn't go through the material, well, if the water doesn't go through it, the bacteria aren't going to grow. Eventually, sometime they will. A better media is this type of more open media. It doesn't have to be plastic. It can be the ceramic. But you want the water to be able to get through the media. And then also what's going to happen over time on all this media is the dreaded heterotrophs. The slimy stuff is going to start caking it. And if the water doesn't go through because it's clogged up, there's no nitrification going on. The water has to bring the ammonia and the nitrite to the bacteria. So I'm not against this type of media. It's just, if this is all you're using in a newly set up system, you're going to find that it takes longer to cycle than using something like a layer of glass beads or a layer of marbles or this type of plastic media. So secret number 3 is provide what I call external surface area during the startup. If you're trying to cycle fast, is media that the water can be in contact with. Don't just think that if I put a bunch of blocks in there that the water's going to get in there and the bacteria are going to grow in there. They're going to grow on the outside first, and it's going to take them a long time to get inside there. Why? Because they grow so slow. They don't hide like a fish. They don't go into the crevices to get out of the way. They just attach to a surface and start growing. Also, bare bottom tanks don't work very well. That's all. I get that a lot. Well, I'm doing a quarantine tank, and I'm having hard time getting my cycle to start. Why? Well, the glass doesn't provide much surface area. And what do? You add maybe a mixture, and you pour it into the tank, and there's nothing to disrupt it. There's really no surface for it to grow, so it goes and gets caught in the filter sock or in the filter pad, and then you clean that, and now you've just washed all your nitrifiers away. Another secret is eliminate competition. I keep on talking about surface. So there's the heterotrophs that have to have, the autotrophs that have to have a surface, the nitrifiers, and then they have their competition, which is the heterotrophs that also want surface area. And a lot of mixtures will have a mixture of the two types of bacteria. And I feel that's a mistake because heterotrophs can multiply in 20 minutes. If you set up a new tank and it goes cloudy the next day, there is no way that is nitrifying bacteria that's causing that cloudiness. They cannot grow that fast. Heterotrophs, on the other hand, they can grow that fast. What are they doing, though? Is they're taking micronutrients, especially phosphate, out of the water. And all bacteria need a little bit of phosphate in the system when they're growing. So if you're trying to speed up cycling, don't put a competitor in there that can grow so much faster and will basically steal all the micronutrients that the nitrifying bacteria need. I talked about the heterotrophs. They can divide in 20 minutes. They use organic sources of carbon, and what they can do is they can crowd out or bury the nitrifiers. So like with sand filters in public aquariums or your cartridge filters, canister filters, it starts to get dirty. You're burying the nitrifiers with organics. So you've taken that 100 micron layer and put a bunch of organic material on it. Heterotrophic bacteria are going to work to degrade or get rid of that organic material, and your nitrification is going to slow or stop because you're not getting the nutrients and the ammonia-laden water to the bacteria. So what this means during cycling is use a pure mixture of nitrifiers. Don't add heterotrophic bacteria. Don't add sugars like carbon sugars that promote heterotrophic bacteria. So secret number 4 is don't promote the competitors during cycling. Don't set up a GFO. Why? Because the GFO is going to take the phosphate out of the water. The nitrifiers need the phosphate. Don't set up denitrification systems because that's going to promote the growth of bacteria that, again, are going to steal the nutrients. Don't dose organic carbon like vodkas and sugars because that all promotes nitrifiers. Wait until the system is established before you start worrying about these types of bacteria and these types of systems. Next, temperature. We grow the nitrifiers between 25 and 30 C Fahrenheit, 84 to 86, 90. I'm not sure. I have to look it up. Sorry, I deal in Celsius. But it's very warm. Why? They grow very warm. Now, if you're trying to do a cold water system, we're not going to talk about this, but below 10 or 50 degrees Fahrenheit, there's a complete species shift of nitrifying organisms. They're not even bacteria, but we're not going to confuse the issue with that because most people don't do tropical marine aquariums below 50 degrees. But if you're trying to do that and you're having problems, come see me. I can talk to you about that. Okay. So secret number 5, increase the temperature. Yes, you're going to keep the temperature maybe at 76, 78 degrees when the fish are in there, but during cycling, crank the temperature up. 84, 85 degrees. Get it cycling. The bacteria will grow much faster, and then you can decrease it a few degrees each day before you actually put your fish or your corals into the system. Lights. Prefer to cycle with the lights off. Why? Because the lights promote algae, or can promote algae, and what are the algae going to do? They're going to take the phosphate out of the system. And most new aquariums don't have a lot of phosphate to begin with, and most people read the internet, and they're worried about having too much phosphate because it's going to turn their new aquarium into an algae bowl. So they do all these things to limit phosphate, and that limits the growth of the nitrifying bacteria. Again, if you lower the temperature, you're growing nitrifiers. Now this is, all bets are off if you're going to do your temperature, your final temperature is going to be below 10. Cycling at 85 degrees and then lowering it to 10 isn't going to work because at 85 degrees you're going to grow one set of nitrifiers. When the temperature gets below 50 Fahrenheit, they switch. So you'll have an increase in ammonia or nitrite. So if you're really stuck on doing some culture of fish below 50 degrees Fahrenheit, you've got to start at 50 degrees below or below with the bacteria. So how do we put all this together in the final few minutes is, first, you need substrate. Bare bottom tanks, you're going to have a long time to cycle, no matter how much live rock you put in there. If you're using live sand, measure the ammonia before you add any ammonium chloride if you're going to do fishless cycling. Why? Most live sand products have a mixture of organics and heterotrophic bacteria that have been sitting in a bag for who knows how long. You open it up, stir it up, put it in the tank, add water. You're adding lots of oxygen to these heterotrophic bacteria. they're going to degrade the organics, and they degrade the organics into ammonia. So you already might have enough ammonia in the water to begin with. So measure before adding any ammonia if you're using live sand. Don't use ammonium chloride with scents or surfactants. You need pure ammonium chloride. Surfactant is basically soap, and you don't want to add soap to your aquarium. Don't dose more than 4 ppm ammonia in the system. It's actually better to add a little bit several times a day. And the other thing, what's going to happen now? You start with this, turn the temperature up, have the salinity lower. I guarantee the ammonia oxidizing bacteria are going to establish first, and you're going to add ammonia, and they're quickly going to disappear overnight. Then people start to freak out. Oh, they're going to starve to death. They have to eat 3 times a day. I need to dose ammonia every day. No, they don't. They're not human. Even humans don't actually have to eat 3 times a day. But you don't have to continue dosing ammonia. The bacteria are not going to starve, because what will happen? We got to let the nitrite oxidizing bacteria catch up. The ammonia is being converted to nitrite, but again, as I've showed earlier, if you let the nitrite build up, it stalls the whole system. And this is the biggest problem everyone has with cycling a new tank, is they let the nitrite get too high for many reasons, and it stalls the whole system. So just be patient and let the nitrite oxidizing bacteria catch up to the ammonia oxidizing bacteria. There's a 3 or 4 day lag with those. Okay. So we set up a tank, we have the salinity around 20, the temperature at 25, media in the system. We have test kits to measure. If you're going to cycle a tank without test kits, it's like driving in the dark without your headlights on. You don't know where you're going, and you don't know if you're going to end up in the ditch. Right? So have some test kits so you can indicate. And don't email me and tell me your ammonia is 0.001 with any off-the-shelf test kit. They're not that precise. They're indicators. Is it yellow? Is it green? Is your nitrite clear or purple? Presence, absence is what we're looking for, okay? And again, as I said, this is a bare bottom tank. Even with live rock, you put some bacteria in there, it doesn't stick. It doesn't automatically stick to the live rock. It gets washed out of the system. They like to attach to a calcium substrate. That's why crushed coral is a really good substrate to use. If you want bare bottom, let the tank go for a while, then siphon out your substrate. But initially, put something in there to capture the bacteria, let them have a surface they want to grow on. The other thing is units. Haven't talked about that too much, but I prefer, because people say, well, I added just 2 milligrams per liter, and now my nitrite is off the scale. Your instructions are all wrong. Well, no, because unfortunately, most test kits measure in the ion. So it's like measuring inches or centimeters. And I prefer to use what's called milligrams per liter as the nitrogen base. It's just a way to have continuity between nitrite and nitrate and ammonia. But I'm not going to go in that. It's a little deep for a beginner class, but pay attention to the units. Okay, now you've got the tank cycled. How are you going to maintain, as we finish up, a healthy biofilm of nitrifiers? Nitrifiers, they grow slow in salt water, as we talked. They spend energy, so lower the salinity. And before they develop, they grow on the surfaces. If they get stressed, they'll start to break up, and you will start measuring nitrite. That's the canary in the coal mine. And the one test kit that it's an easy test kit. The reagents last a long time. If that's one thing you're going to measure, is measure nitrite on a regular basis. And if it starts to appear, that tells you there's something wrong with your biofilter, because these bacteria will always stress first and stop converting nitrite to nitrate. I know a lot of companies want you to worry about ammonia, but it's really the nitrite that tells you way ahead of time that something's happened. You have a clogged filter, you have clogged water path, something's wrong with your biofilter, and the bacteria are not working well. Okay? If you're interested, all this is based on a lot of research by myself and other researchers. The University of Vienna has a whole institute dedicated just to nitrite oxidizing bacteria, and I'd be glad to answer questions, and thank you very much for your attention.